Hello, Coach Travis here with another pre-calculus video. So what I want to do in this video is show you how you can use GeoGebra to graph a piecewise defined function. So piecewise defined functions look really complicated and yeah, they are rather complicated and drawing their graphs can be kind of tedious. But with GeoGebra we can draw the graphs if we know what to tell GeoGebra. So we do have to be a little bit careful. What you type into GeoGebra is going to be a little bit complicated, but at the end of the day, you get a nice result out of it. You get a nice picture that GeoGebra will draw for you. So let me see here. So one thing you can do here, let's just start with this function. One thing that a lot of people do is you can just graph these three functions separately. So in some sense, that's the easiest thing to do, but it's not necessarily the best thing to do. So for example, I could type g of x is equal to x plus 2. All right, so it just drew the graph. What I just drew here was the graph of the first part of this piecewise function. But this isn't really the right thing because I'm only supposed to have this picture when x is less than -1. So there's actually a nice easy way you can fix this in GeoGebra. So what you can do is you can add to your function. So you can type a comma and then in parentheses put x is less than -1. And you can see that, oh, okay, so more or less it drew the right graph there. It restricted the domain to just x values that are strictly less than -1. Now again, GeoGebra is not perfect because what GeoGebra really should do is it should have a little open circle right here to indicate that x is equal to -1 is not part of this function. But GeoGebra doesn't do that. So we'll have to we just should imagine that there really is a little open circle right there. So now what I can do is graph these second two functions. So I'll type h of x is equal to x squared and then comma. And now this time -1 is less than or equal to. So notice in GeoGebra to type the less than or equal to symbol, you type the less than symbol and the equal symbol. Or also, I think you can probably use a palette over here. Yeah, you can get it over there too. But I prefer to just use the keyboard. And that's less than x is less than 2. So there you go. So now you've got the graph of a parabola. But that parabola only exists between x is -1 and x is 2. And then finally, say k of x is equal to 3. And that time, this applies when 2 is less than or equal to x. And there you go. So we have that. So in some sense, these three functions put together give us the graph of this function. But this is a little bit, this is less than ideal because we had to do three separate functions, whereas what we really wanted was a single function. So, if someone asks me what f of 3 is, then I can't just type f of 3 into GeoGebra and have GeoGebra tell me what the answer is. I have to think about it. I have to look at the picture, and I have to say, oh, well, let's see, when x is 3, that means I use the k function, so then the value of the function is 3. So anyway, this is one way to do the problem, but it's not necessarily the best way to do the problem. So what I want to do is show you how GeoGebra can actually really you can define this function piecewise as a single function in GeoGebra and not have to use three separate functions. So, all right, so the idea here is what I'm going to use is I'm going to use the if operator in GeoGebra. So I'm going to type if, and then it auto completes for me here. So the idea is what I give it is a condition and what to do if it satisfies that condition, and then what to do if it doesn't satisfy that condition. So in this first part, if I look at the first condition here, is x has to be less than -1. So I'll just type x less than -1 here. So that's the first condition I have to satisfy. And if that condition is satisfied, then the value of the function is x plus 2. So I just type x plus 2. So if you've done any computer programming, this sort of if operator should look very familiar. And okay, then what do we do otherwise? So, okay, well, otherwise we go on to these other two situations. So let's just go to the next one. So the next one, I'm going to need another if, because this next function only kicks in if certain things are true. And so, okay, so now I have to tell it what's the condition that I want to be true. And so, okay, so to use this second function, the x squared, I need to have -1 be less than or equal to x, and x needs to be less than 2. So that's my condition. And if that condition is satisfied, then my function is going to be the x squared function. And if that condition isn't satisfied, okay, now we go on to this last one. So, all right, so I need another, but again, this last one is a conditional. So that means I need another if statement. And this time I just need a condition. I don't need an else part because there's nothing else that's going to happen. So I just need a condition and a result. So, okay, so in this case, the condition is 2 is less than or equal to x. And what we want to return in that case is the value of the function should just be 3. And there you go. As soon as I finished that, look at that. It gave me, it drew the graph. So what we've got here is we've got the graph, and it's just one single function this time. And this is going to be handy for us because if we just want to know some values, like if I want to know what f of 3 is. So we already decided earlier that it actually should be 3, because when x is 3, the value is 3. But let's just check. Sure enough, f of 3, well, f of 3 is equal, well, I guess for some reason it changed it to the letter A, but it returned 3. Okay, and then what if I want to know what f of -4 is? Well, I could figure it out, of course, just by looking at the graph, but GeoGebra will tell me, okay, f of, let's see, can I highlight it here? Yeah, there it is. F of -4 is equal to -2. And that's exactly what the graph told me. And if I want to be really fancy, I'm putting some complicated number like 0.687. And there you go. So f of 0.687, or I guess it rounded, f of 0.69 is equal to 0.47. So it's plugging it somewhere in there. So it did require a lot of typing. It required use of conditional statements, but the end result is actually awfully nice, that we get one self-contained function and we have the graph of what it looks like.